Okay, so, we are talking about 𝜖-NFA. So, just to recap, it is a 5 tuple. So, Q is the set of all possible finite state, and this sigma is the set of all possible finite alphabet, and that here the transition rule is Q cross 2 to the power q, the power set. So, it can take so here we are allowing to have a epsilon move. So, that means the without seeing any tape in the without seeing any alphabet in the tape, it can move automatically. So, this is a extra added feature there. So, and then this is the starting state, this is the final state. So, now we are going to extend this delta to delta h. So, for that we need to define the epsilon closure. What do you mean by epsilon closure of a state? So, here we are allowing epsilon move. Epsilon move is just there is no input, still our system is moving from one state to another state. So, epsilon closure of q is nothing but its set of all states q1, q2, qk such that from q we should able to move to the states only with the epsilon move. So, only with the epsilon move. So, that means we are at q. So, we are at q. So, if we q1 all the epsilons q2, q3 dot 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 qk. So, all are epsilon move. So, only by epsilon move we should able to reach to these states, then it is called epsilon closure. This set of all state will call epsilon closure of q. So, we can take an example like last example we had in the last class. So, if we take this q0, q1, q2 and we have this is our starting state, this is 1, this is 2, this is epsilon move. Okay. Now, suppose you want to find the epsilon closure of q0. So, epsilon closure of q0 means from q0 with the epsilon move wherever we can go. So, we cannot from q0 we cannot go to q0 with epsilon move, but we can go to for q0 epsilon move we can go to q0, because that is always there. Delta of q0 epsilon is always this is always q0, because if we are at q0 without seeing any tape we will be remain at q0. So, this is by default. So, this set is q0 and with epsilon move we can go to q1, and with epsilon move this is epsilon, this is another epsilon, you can go to q2. So, this is the epsilon closure of q0. Okay. Because from q0 with epsilon move we can add q0, and with epsilon means no input, and q1 we are going now to go to q2 we have to go to q1 with this epsilon move, and then from there q2. This is q0. So, this is the set epsilon closure for q0. Now, what is the epsilon closure for q1? Epsilon closure for q1. So, epsilon closure for q1 is we can q1 will be there and q2, and epsilon closure for q2 is only q2. Although there is no explicit epsilon move for q2, but if we are q2 and if we are not seeing any tape, if we are not reading any tape, we will be remain at q2. So, that is by default. So, that the epsilon of if we are q, this is always q. Okay. If we are not seeing any tape, any input in the tape, we will be remain at that state. Okay. So, this is the way how we define the epsilon closure. So, epsilon closure is a path. So, it is the from only epsilon move we can reach from one state to another state. So, that will be the epsilon closure of that state. So, we have recursive construction also for epsilon closure, that is like this. So, the arc will be labeled only by epsilon. So, this is the recursive construction recursively. So, first one is q belongs to epsilon closure of q. This is by default, and if p belongs to, this is belongs to and this is epsilon. So, you can take a big, this is belongs to, this is epsilon. Epsilon closure of q and r belongs to delta of p comma epsilon, then r belongs to epsilon closure of q. What is the meaning of this? Meaning of this is, suppose we are at q. Now, only by epsilon move, suppose we are reaching to p. This is only by epsilon move. This contain all the arc which are labeled by epsilon. Then we if we have another epsilon move to r, then obviously r will belongs to, because by only epsilon move we can reach to r. So, that means r belongs to closure of epsilon closure of q. So, that is the meaning of this statement. Okay. So, so even we can have if from q, say if p is going to r1, r2, all the states, rk. So, that means delta of p comma epsilon, if this is the set r1, r2, rk, then all this r1, r2, rk. So, then we have a p over here, q over here. Suppose we are only by epsilon move we are going to p. So, all this r1, r2, rk will be belongs to epsilon closure of q. So, this is the recursive definition. So, basic idea is to just we move from one state to another state just by reading the, just by having no input, the epsilon move. Okay, just we see the all the arc which is labeled by epsilon. So, that is the meaning of this. Okay. So, now with the help of this we just extend this delta to delta hat. So, with the help of this we just extend delta to delta hat, extended transition function. That is called delta hat. Okay. So, we know delta is nothing but q cross sigma with the epsilon is going to power set of q. It is a subset. Now, we want to have a delta hat which is q cross, it should take a string instead of a single alphabet or the epsilon move. This will also go to the power set of q. Now, how to define this? So, to define this, the base case is same, delta hat of q epsilon, because epsilon also belongs to this. Okay. So, this is basically epsilon closure of q. Because we have a epsilon move here. So, this means we are at q. Now, this is the all the epsilon move wherever we can reach. So, this set is basically this. This is nothing but delta of q comma epsilon, but this includes q. Okay. Because if we add q, this union q. Q is there, because if we are at q, if you are not seeing any input, if you are not reading any input, we will be remain at q. That is one thing. And another thing, now we have a option for epsilon move. Without reading the tape, we can move. So, that is the we can go from q to with epsilon move, we can go to these are the states. So, these are all will belongs to this. So, this is the base case. Okay. Now, we extend this for other than epsilon. So, general W. So, W is equal to x a. So, here x is a string and a is an alphabet. Now, how to define this? So, delta hat of q x a. So, the idea is we are at q. Now, we are reading this x and we will be going to some states r 1, r 2, r k say or r l. Okay. Now, from here we can have a epsilon. So, from here, so we can have a epsilon before that and after that also. So, what is the convenient? So now from here we can have a, we can go to P 1, with a we can go to P 2. So, maybe this includes the epsilon move after R 1 and before R 1. So, dot 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 dot. So, like this. Now, for all of this we can have now epsilon closure. So, this set will be the delta hat of this. Okay. So, let us write this formally. So, let me write this formally. So, we are defining delta hat of q comma x a, which is nothing but epsilon closure of the set P. So, epsilon closure of a set P is nothing but, so we can say that union of the epsilon closure of P, where P belongs to capital P. So, what is capital P? Capital P containing the set P such that for some R belongs to delta hat of q comma x and P is in, after the R we have take the A, P is in this. So, this is the meaning. Meaning means we are at q. Now, we go to some R with the x. This includes epsilon move is here. So, there are many such R's, but at least one R. So, it contain all such P's, and then from here we have many P's. This is one of the P, because this is NFA, this is one of the P. So, after that we take all such P's and their epsilon closure. So, this is the epsilon closure of. So, this is for one p. So, we have many such p's over there. So, this is how we define this. So, basic idea is we have a tape. So, we have given a tape of alphabets. So, this is our x, this is our a. Now, we keep on read the tape, and sometimes we will see the possibilities where without reading the tape we can move or not, that is the epsilon move. So, that also we will explore those branches. So, there are many branches over there. So, those branches also we will explore. Then finally, after exploring all such R's, there are many such R's, and P is there are many such P's. So, this is R 1, this is R 2, we have many such P's. So, from there we can go to epsilon closure of this. So, this way we can take all these epsilon closure of P, those will be this delta hat of this. So, delta hat of W means we just read the string, sometimes we do not take the input, we move, and then finally, we reach to the sum of the states, which include the epsilon move also in between. Many epsilon moves are going on inside. Okay. So, this is the way we define the delta hat. So, now we can define the language of this 𝜖-NFA. So, from delta hat we can just extend delta and delta hat to the set of state inside of a given state, to the set of states. So far we have seen we have a set Q and the delta is just a direct move. It could be epsilon move also, and this is the set. This set is delta of Q comma A, or A belongs to, it could be epsilon also. Okay. And the delta hat also we have defined Q, we take a W. So, we are including the epsilon move, we are reaching to this set, this is a delta hat of W. So, these are on a state. Now, we want to define this set of states. Instead of a state, if we have set of states, from that set of state where we can go. So, that is basically just the union. So, that is basically just the union. So, delta now R is a set of state of A is nothing but union of delta of Q comma A, Q belongs to R. So, we have inside of a single state, we have many state, say Q 1, Q 2 like this. So, on this set by delta where we can move. So, that is the way we are defining. So, this is the delta of R comma A. Okay. Just to because here we are having it is non-deterministic. So, we are dealing with the subsets. So, that is why it is easy to have this, and then delta hat of R comma W is nothing but union of delta hat of Q comma W, Q belongs to R. Similarly, instead of alphabet, if we read a string, where it can go. So, this is the way we are defining. Okay. So, now we are going to define when a string is accepted by the 𝜖-NFA. Now, there is an observation is delta hat of Q comma A is not necessarily equal to delta of q comma a. Yeah, because this is epsilon NFA. For epsilon NFA, what we have? So, delta hat of q comma a is the set of all state reachable from q by a path labeled by a, including the path. So, we are at q. So, we are reaching to only a, or because a consists of, we can write a epsilon over here, epsilon over here. So, we can just see a epsilon before a, we can see a after a. So, this is a string. Now, once we define this, this is not a, this a will be treated as a single alphabet, it is not a string. So, there is a fundamental difference between this. So, here we are allowing the epsilon move, but there a could be epsilon, that is fine, but other than that it is just a input alphabet. So, this is a fundamental difference between these two. Okay. So, and now we define when a string is accepted by a epsilon NFA, w if delta hat of, we are at q 0, if we say w, if this intersection f is not empty, that means from q 0 there will be many paths going. If one of the path reach to a final state, then these are all w's, then we call w is a accepted by the epsilon NFA. Okay. We can go back to the last example, and the language of this is, the language of the epsilon NFA is nothing but set of all w such that delta hat of q 0 w is not null. So, this is the language of the epsilon NFA. Okay. So, this is the language of epsilon NFA. Let us take the last example, and later on we will see the from epsilon NFA we can have a NFA, and then from NFA we can have a DFA. So, that means all are basically accepting the regular language, okay, but it is not going beyond the regular language. So, that is the one thing, although we are making our life easy by introducing non-deterministic, by introducing the epsilon move, because with epsilon move it is easy to construct a finite automata for a given regular language, but it is not, we are not going beyond the regular language. So, that will go after that, after this topic. So, let us take that same example from the last class, q 0, q 1, q 2. So, this is the starting state, this is epsilon move 1, this is epsilon move 2, then this is the final state. Okay. Now, here that is why delta of q 0 comma 0, delta of q 0 comma 0 is q 0, but delta hat of q 0 comma 0, if we consider, because delta hat consists of, when you talk about delta hat, this we treat as a string. So, this 0 means epsilon here we can say. So, this is nothing but epsilon closure of all possibilities. So, this is basically q 0, q 1, q 2. So, this is the fundamental difference between these two. So, from q 0 we can go to, by epsilon move we can go to, because here in this definition we are not allowing the epsilon move, this is the function direct transition rule, but here we are allowing the epsilon move, that is the fundamental difference. So, we can go to P 1, P 2, this is just by epsilon move, P k. Okay. Then after that we can see a alphabet, these are all going to R 1, R 2 like this. This is a set, R 1 set, this is also going to some set, R 2 set, and again after that we have a epsilon move, epsilon closure of this. So, you can understand. So, we can have a, so this 0 when you talk about the hat, this 0 can be treated as epsilon 0 epsilon. So, this epsilon move, this will include the epsilon closure of every this state of this set. So, this is the freedom we have. We have a epsilon move, that means without seeing the input we can move to one state to another state. So, that is the difference between delta and delta hat. So, if we just take this delta hat of q 0 0, we can go to delta hat of q 0 epsilon 0, because epsilon move we can go to q 1. So, this is the epsilon closure of delta hat of 0 like this. So, this way we will reach to the q 0, q 1, q 2. Okay. So, similarly, if we want to find out the delta hat of q 0 0 1. So, this is by definition we know this is we are at q 0. So, we first apply all the epsilon move on this, epsilon closure of this. So, if we apply all epsilon closure on this, so we will go to q 0, q 1, q 2, then we can use this 0. So, from here if we use 0 we will be at q 0 again, there is no 0 move here. So, we will be remain at this, and then again we can go for epsilon move. So, if we go for epsilon move, this is the epsilon closure of this set. So, this is q 0, q 1, q 2, and we can have a epsilon move for this. So, this is again q 1, q 2, and this is again q 1. So, these are the set q 0, q 1, q 2 is again the this. So, this is the way. So, we have the epsilon option from the both side, before string, after string, before alphabet, after alphabet. So, it is a extra feature you can say. Okay, so, we will continue this. Thank you.